Hello? Oh, there we go. Am I on? Excellent. Right, I'm going to get kicked off. Has everyone got a beer? Yes. We good? Excellent. So, CSP, XXP, STS, PKP, CAA, ETC, OMG, WTF, BBQ. This is my talk today, and I can hear all of you thinking the next acronym in there, which is FFS. So, the friendlier and more sane version of the title here is probably Modern Web Security Standards. This is what I'm going to be talking about. And the title is kind of on purpose. I want to kind of cut through this acronym soup that we end up with and all of this confusion around these different technologies, because a lot of them, when you allow them to be, are really simple and can help you an awful lot for close to no input, like as little effort as is possible for some of these. So you can probably think of the talk more as a series of lightning talks to introduce you to each one of these different technologies. So you can learn, are they applicable to me? Could they help me? How can these things make my lives easier? Because I'm a security guy, and this is a security talk, but a lot of these things can just make your lives easier as developers, and this is why I use them a lot of the time. So I'm going to get kicked off, and I'm going to dive right into it. And the first acronym from my title is something called Content Security Policy. Now, if you've seen me on Twitter before or anywhere else, or even speaking somewhere else, you'll have probably heard me talk about CSP already. CSP is an immeasurably powerful mechanism, and it can do so many different things for you. And it was originally designed to stop something called content injection attacks. And what I mean by that will be that something that perhaps looks like this. So you have your web page, and you have a lovely review section at the bottom. And you want people to click on the 5 stars and type how awesome your product is, and they submit it. But some sneaky person will write their review and include some HTML code in there. They might put a JavaScript tag in like this. So you save their comment into your database, and then you render that comment onto your homepage and say, look at this great 5-star review we got. And that comment has this script tag in it. Now, show of hands, who wants this script tag loaded on their homepage? Exactly right, and why don't you? Because we, as humans, can look at this and say, right, well, we've got this script tag here, and it's been loaded from evil.com, which is probably not a good start, and it's also called keylogger.js, which is definitely not what we want. But the browser doesn't have that level of context and understanding like we do. The browser is parsing the HTML, it sees a valid script tag, and it goes and fetches the script and places it into the page. The browser doesn't have the information it needs in order to make that assessment of whether or not it should load this particular script. And we can make this even harder for the browser because we also have things like inline script. And these kinds of attacks are called XSS, cross-site scripting. And this one's even more difficult because whilst the example here is particularly harmless, do you know whether I as an attacker put that there or whether the host put that there themselves? And it's supposed to be a genuine script on the page that should be there. Now we have no point of reference. We have no evil.com. We have no keylogger.js. So inline scripts like this are even more difficult to deal with because we don't even have any information to make the decision on with what we should do with this script. And these two things are what CSP was originally created to fix. They're content injection attacks. They're called cross-site scripting. But CSP has evolved, and it can now do so many more things for you. So we're going to look at what CSP is and how we deploy it. So CSP, Content Security Policy, is what we call a security header. It's a HTTP response header that you use specifically to configure a security mechanism, a security feature. So you can see it alongside other headers here that you're probably somewhat familiar with. You define the Content Security Policy header, and then you put your policy in the header. So it goes along with the page to the browser, and you say to the browser, here is the page, and here is the policy that I want you to enforce. So we need to build a policy. The policies are built of what we call the directives. So within CSP, there's a whole bunch of directives. This is a subset. This is not close to all of them. But these ones control different locations the browser is allowed to load content from. So if you were to specify the image source directive, you would then give the browser a list of domains. And that means that the browser is permitted to load images from those domains. So you say, here's the image source, here's my CDN, and Facebook. These are the 2 places that we can load images from. You would specify the font source and say, this is where I load my fonts from. And things get really interesting and really powerful when we do the script source, because you say, this is the place or the places that I load all of my scripts from. So you take a policy, you build a policy. This is probably the most basic example of a CSP that I can give you. So we've defined the content security policy header here. And on that previous slide, there was the default source. Now, if you want to be fairly relaxed and kind of laid back about it, you can just say, by default, we'll load from these different locations. And that means any content can be loaded from these locations. Scripts, images, styles, everything. Self is a keyword in CSP, which means my own website. So by default, I'm happy to load things from myself. Hopefully, you should be. Otherwise, you've got issues that I can't help you with. And we can load things from this other website as well, from cdnjs.com. So you send this to the browser, and already we've neutralized the two attacks that I just talked about, the two cross-site scripting ones. Because the first one, it'll look at the script tag, and it'll go into the source attribute and say, right, evil.com, we're trying to load a script from evil.com. There's no script source specified, so I'll check the default source. Evil.com's not in the whitelist. And the browser will simply skip over that script tag and won't load it. So we've completely neutralized that first attack vector. And the second one, the inline script, one of the things that you get by default with CSP is that the browser won't execute any inline scripts. And this is because of the issue that I said, in that you don't know where it came from. You have no information to make the decision on. So what you do is you externalize it into a file, load it from your own domain, and then we match on self. So you can still have the script in the page, just not in line. And already we've completely neutralized XSS, which is a huge problem on the web. It's still one of the most common attacks that we see. But I couldn't deploy that on my website, and I'm pretty sure that you couldn't deploy that on your website either, because we all load content from like a bazillion different places. So you need to fine-tune your policy for your website. So we go default source self. By default, I'm fairly happy to load things from my own domain. And then I specify the script source. We want to get more specific now. When you specify a new directive like this, it overrides the default. You don't inherit from it. So if you want to load scripts from yourself, you need to specify it. And then I've put these two CDN domains in there. And what this means now is that I can have script tags like this on my page. The browser will come through. It'll look at the source attribute and say, OK, yep, Google CDN, that's good. Cloudflare CDN, that's good. We can load both of these scripts. So you do that for the script source, and then you continue fine-tuning your policy. We call them source lists. So you say, OK, these are all the locations that we want to load scripts from. This is where we load styles, images. We can control things like iframes. Who are you allowed to put in frames inside your site? And you can start to build this policy, and you can start to get really specific with that. But this is, as I said, this is a subset of the directives. So this controls where we're allowed to load different types of content from. But you can also control certain actions that the browser is allowed to take as well. Because there's more directives, and there's more directives than the ones I'm going to show you in total. And I really like things like the form action. So when I was talking about the example of someone leaving a review and writing a script tag in there, what if they wrote a form tag instead? We've still got a problem, because the bad guy is probably going to write a form tag that looks a little bit like this. And maybe they could trick a user into thinking, oh, this is the login button for the page down here at the bottom. We'll style it, we'll make it look good. And the user types in their username and password, and where is it going? The browser will quite happily send it to this other website again, because it doesn't know that it's not supposed to. The form tag is valid. We have the action. We'll send the username and password there. And hopefully none of you want your usernames and passwords to be able to be sent to evil.com. But the browser doesn't know that. So you can specify the form action and say, look, this is where you're allowed to post forms to on my site. And most websites, it's just self, because you generally only have a login on the same domain. Or you can just specify the domains that you want it to be able to post to. Frame ancestors is another good one. This controls who is allowed to frame you. And we see a lot of attacks like this, especially on financial sites, where rather than kind of ripping off your homepage and trying to make a convincing-looking login form, what an attacker will do is they'll get their site and they'll load you in an iframe. So it is your website, you're in an iframe, and then they'll overlay a transparent form on top. So when the user clicks on what they think is the bank's login field, they're clicking on the transparent one overlaid on top of it. And it's a really simple attack called clickjacking. And it's basically just lazy people that don't want to build their own login forms. So they'll just frame you. With frame ancestors, if you try and do this with my website, you will see that it doesn't work, because I use frame ancestors in CSP to say, look, nobody's allowed to frame me. My website does not go in an iframe. And that's it. Problem solved. Things like block or mix content. This is a really good one. It's fallen out of favor now and it's kind of been replaced with upgrading secure requests. But if you have a website on HTTPS, most people are either on HTTPS already or are moving, will soon be moving. And when you go to HTTPS, you need to have all of your things loaded over HTTPS too. So all of your images, your style sheets, your scripts, your everything has to be HTTPS. Otherwise, you get little warnings in the address bar that say something is wrong. So if you were to put this onto your HTTPS website, you lose your green padlock that you did all of that hard work for, and it turns yellow or maybe red. Depends on the exact browser. But this will break things. This will give your users errors because you've somehow let this asset slip through to production. It happens. You know, we have the common one that I see is like content writers and blog writers just copy and paste things from all over the internet into their articles. Upgrading secure requests tells the browser to look at that and rewrite that tag for you. So the browser will actually take that image tag and rewrite it to HTTPS. Because upgrading secure requests says, look, if there are any insecure requests on this page, just upgrade them. Like, I don't want them to break things. I don't want my users to see errors. Automatically fix it for me and just don't pester me with this thing. And we're going to look at all of these in action. I'm going to give you some demos of this kind of stuff in action. But the one thing that we need to consider is that CSP is quite powerful, because what happens if you forget to whitelist the place that you load your style sheets from, and the browser refuses to load style sheets on your website? What's your website going to look like? It's going to look crap. So you can break things with CSP. Most security mechanisms, most features, in fact, you can break things if you deploy them wrong. So it's really essential that we know how to test CSP before we deploy it. And you can test CSP with zero risk on your website. And what you do is you send exactly the same policy that you've built, but we change the name of the header. So we change it to Content Security Policy Report Only. And when you send the header with this name, what it says to the browser is, look, I'm thinking about deploying this policy. Tell me what would happen if you enforced it. Don't enforce it, just tell me what you would have done. And the browser will pop up errors in the console for you and say, right, okay, if I got this policy on this page, I would have blocked this image, I would have blocked that script, and this style sheet over here would not have been loaded either. And you can say, great, okay, maybe we've missed them, or maybe you actually have things that shouldn't be there. But you get that feedback, but nothing happens on the page. It's not going to completely tank your website. But this means that you need to go to the page and look in the console, which kind of sucks, especially if you're a big website with hundreds or maybe even thousands of pages. You could have localized content, you could have all kinds of crazy stuff. So this doesn't really scale. And there's a solution for that as well. It's called CSP reporting. Now, again, it's a very similar kind of mechanism. What we do, we have the header in report-only mode, and again, we send the policy. But this time, you add this new directive on the end called report URI. And what this does is it says to the browser, look, instead of just writing this error into the console, I actually just want you to send it to this location. I want you to send me a report, and it will post a JSON payload to that endpoint for you. And the JSON payload has all of the information in it that you need to find the issue and rectify it. So it tells you the document URI. I know that on this page of my blog, there is a problem. It violated the script source, so I know there's a script on there that shouldn't be there. It gives you the original policy, so you can see what the browser was working with, and then it tells you the blocked URI. So I can look at this and say, wow, okay, if I go to this page on my blog, there's a script tag on there trying to load from evil.com. I should probably go take a look at that. Now, in report-only mode, the browser will not block it. So this is just giving you the feedback, and you can put this into your production site. And the thing that I like about this is that you're kind of turning all of the visitors to your site into kind of your QA team, your security testing team, because each time a visitor comes to your page, they will say, oh, I came to your page and this thing was wrong. Here's a bug report. And it's nicely formatted, it has all of the correct information, and you'll never get that from your QA team. I can say that I was a QA. It's okay. So I want to show a couple of these different things actually in action, because it's great to talk about them, but it's even better when we can see them. So I've got a few different demos set up, and if you follow me on Twitter, what I'm going to do is I'm just going to tweet the links out to these at the same time, so you can actually go and have a look at these afterwards. I'll leave them up. So I have a page here on my blog, and it's got a few different examples set up on it. So let's dive into the console and see what's going on with this page. So I'm going to reload that. And straight away, you can see that we've got two errors in the console just over to the side there. So if I take a look at this script tag, this particular one here. So can everyone see that? Is that big enough on the screen? So I've got an actual script tag in this page. This is like a genuine real script tag. You can go inspect the source. And it's genuinely trying to load a keylogger from evil.com into my website. But of course I have CSP deployed. And that has not happened, because if we come down here and take a look, it says, refuse to load the script, evil.com/keylogger.js, because it violates the following content security policy directive. So because I have this header in place, the browser comes through and it parses the page and says, okay, we've got this script from evil.com, but it's bad. We're not going to load that. We're not going to put it into the page. Now, the next one, I'm going to skip over the form for a second, because you can already see the second error in the console. And the second error in the console comes from this particular image here. And what I wanted to show was upgrading secure requests in action. So again, somehow, somewhere, I have accidentally put a HTTP asset onto my page. It could be an image, it could be a style, script, doesn't matter. But somehow this thing got there, and this thing shouldn't be there. So if I take that, though, and if we go look at the network tab for the requests that loaded this, and if I can find it, if we take a look at the request that was made to fetch that image, even though the script tag said HTTP, just like I said, it actually made a HTTPS request. Now, it tried to make that secure request. It upgraded it to HTTPS, but it still didn't work because of the image being blocked by my CSP again. So it now says refuse to load the image, HTTPS, because of upgrading secure. But still, evil.com is still not in my whitelist. I still don't want to load pictures from evil.com, even if we're loading them over HTTPS. So this works. This actually happens. And the one that I really like, and the one that bizarrely I see used the least often, is this one. It's the form action. So if we take a look just here, let me actually just dive straight into the form. So you can see that I've got this. This is actually like a real form again. I'm actually going to do this. The form action on my website. Now, any normal website, if you could inject this form as an attacker, as a bad guy, I can do this. There's many different avenues. It doesn't really matter how it got there. If I put my username and password in there, do you want this to actually submit? And hopefully the answer is no. It doesn't matter what your website is. Hopefully the answer to this question is no. But if we try, I'll actually put, I'll tell you what, let's put a real one in. So if I hit submit now, we all agree that normally this should just fire, and it would send a post payload with my username and password. But if I press it, and I ignore one password because I'm not going to save that, we can jump over to the console, and you can see again now, we've got another error that's popped up. And it says refuse to send form data to evil.com/steal password, because it violates the following content security policy directive. And as I said, most people, hopefully, it's probably just going to be form action itself, because you generally don't really post data to too many places, but if you do, you can just specify them. Now, there's no real reason, especially on your login form, that you want that to be able to send anywhere else. I can't think of any legitimate time when you would want to be able to send your login form to anyone else but you. But I really don't see that many sites using this. It's a very rare thing. And the last thing that I just want to quickly show, if I do jump over to the network tab, what we can see here, I talked about the report URI and that value where you could send that report. So if we look here, you can see that this page made a request to my report URI value. Full transparency, I run this service that I'm also using myself, of course, and it sends that post payload out to the address that you specify in your policy. So if I zip down to the bottom, you can actually see this is the actual JSON payload that the browser just sent. So if you, as a general user of my site, came to that page and you tried to actually log in, not only would the CSP have saved you and not allowed you to submit that form, but your browser would then tell me that it happened. It would say, hey, look, someone's just come to your website on this page. They tried to send a form action to evil.com. And as the host, I could look at that and be like, whoa, we've got a pretty serious issue on our website. We need to go fix this. So having a CSP is great. It's really powerful. It will help you do a lot of things. But I also think that reporting is just as important, because if you have a problem on your site and your CSP and the browser is taking action to protect you or your users, you should know about that. You need to know about that. So that's CSP in action. As I said, these are kind of lightning introduction talks to all of these different kinds of technologies. So have a look at CSP. There's a lot more that it can do for you. But I want to keep going. I want to keep moving forwards. And the next thing that I want to talk about was XXP, the second acronym in my slide title. Now, XXP, or XXSS protection, as it is called, is another HTTP response header. And we actually use it to configure the XSS auditor in browsers. Now, every browser has one of these auditors built into them. If you're running any good or modern browser, it will do. And what these auditors do in these browsers is they try and detect some of the attacks that we just talked about. And they try to detect them automatically and take action to protect you. And that's good. Most of the time, that's really good because we want the browser to try and detect these things, and we want the browser to try and save our users in the instance that they're under attack. But they aren't always perfect. We have seen instances in the past where the auditors have been abused, and they've been tricked into doing things when they shouldn't have done things. And this leads to some fairly interesting results. Now, they've asked me not to talk about the different auditors and which browser has the best one and which one has the worst one. So I'm not going to do that. And we're just going to talk about what XXP is. And again, as I said, it's another security header. It's a HTTP response header. You define the header, you send the header along with your pages, and again, you put the policy in the header itself. Now, the good thing with XXP, compared to CSP, it's super simple. I can actually just show you all possible values that you can send because the list is that short. This one turns off the auditor. You send this header with your website, and it says to the browser, look, I am so happy with my defenses, I don't want you to take any action. Now, this is really only for very brave websites. And the only big website that I found that uses this is Facebook. Facebook are so confident in their own defenses, they don't want to risk the browser's auditor being used in a way that it shouldn't. So they actually set this header. You can go to their site and see it. And they say, look, turn off the browser defenses. We're happy with our own. Probably not for most people, though. The interesting thing is that most sites don't issue this header. And if you don't issue the header, it actually defaults to this next value, which is where the auditor is enabled. So by default on all sites, unless you configure it otherwise, the auditor is running and will actively try and protect the users of your site. After that, you can then specify the mode value. And this is really interesting because in the default setting, what the auditor will do is it will just try and scoop things out of the page that it thinks are bad. So it's like, okay, we've got this page. This script tag looks nasty. We'll just take that little bit out. When you set it to mode block, what happens instead is it just refuses to render the page. And it says, right, okay, there's something bad on this page. I'm not even going to render it at all. And this is the value that I recommend that most sites should be using. And you'll see why in just a moment. And the last setting that you can do, again, you can ask it to tell you. You can say to the auditor in the browser, look, if you take action because you think there is something wrong on my website, great, take the action, save the user, but also tell me, please tell me I have something wrong on my site, because otherwise you as the host, we won't know. So again, I think that the reporting is a really valuable part of most of these mechanisms. So let's look at it in action. Again, it's nice to give demos of these different kinds of things. And I've got a couple set up here for that. So this page here has a script loaded inside it. You can see an example of the script tag is just there. And it's just a very simple alert script. So if I just reload the page, it pulls in a script file that just throws up a JS alert. It doesn't do anything particularly fancy. You can see, let's have a look at the script itself. So here is the script tag, and if let's have a look at that. Just really simple, doesn't do anything, okay? There's nothing hostile about this. The auditor will have looked at this, and the auditor has allowed this to run, as you would expect. There's nothing bad happening here. But, as I said, we can trick the auditor in the browser. So what happens if let's take a copy of this element, and what I'm going to do, I'm just going to make up a get parameter, and I'm going to paste the script tag into this get parameter. Now, when I send this request, I'm going to reload the page with a get parameter. This is just my blog. It doesn't do anything based on the parameters. It literally doesn't care. But if I rerun this now, where's my alert box? I have no alert box anymore. And if we take a look, there's actually an error down in the console. And if I zoom in on that for you, it says the XSS auditor refused to execute a script in this page because its source code was found in the request, is the end of that sentence. And what this means is the auditor has seen me send a GET request to this server with this script tag in it. And when the page came back, the script tag was also in the page. And the auditor's like, whoa, if you send the script comes back, like you're injecting, the auditor thinks that I have put that script tag into the page, but the script tag was already there, but the auditor doesn't know that. I've tricked it into removing that script tag from the page. If we go look at the source of the page now, the exact same page, look at the source of that script now. The auditor in the browser has stripped that script tag out. Now, this script was harmless. It didn't do anything. But what if that was part of your redirect flow in OAuth? What if it was some fraud detection script that would profile users and look for, what if it was functional? The point here is that we don't want people to be able to choose what scripts we can have in our site. You can put multiple get parameters in and just disable multiple scripts on the page and then send that link to someone. And when they click it, their browser will do the same thing. And that all happens because this page doesn't define a policy. We've left the browser in its default mode. So what we need to do instead is this page, I have configured a policy, and I've configured it into block mode. Now, again, we can take a look at the page. It's exactly the same script tag in there. And what you'll see if we do it on this page is some slightly different behavior. So exactly the same script tag. Oh, I'll reload it and prove that it's there. So it throws the alert. But this time, I'm going to copy the script tag and go through exactly the same process. Just make up a get parameter, paste that in there. Except this time, the page doesn't load, because this is what happens when the policy is in block mode. It says here, Chrome has detected unusual code on this page and blocked it to protect your personal information. And the error message is error blocked by the XSS auditor. Now, again, the auditor has detected an attack, and it said, look, there's something wrong in this page. In the previous example, it just scooped out the bad script tag and loaded the rest of the page, which gives the attacker the ability to control what happens. Whereas with this one, it's like, look, if we say there is something fishy going on this page, should we even really load it? Like, can we be sure that we can fix that with no context and no information and allow the user to continue? And I think this is why block mode is much more important, because the auditor can't be abused. And in both of these scenarios, I will have gotten a report sent back to me to say, hey, I'm the XSS auditor calling in just to let you know that on this page, this thing happened, and here is all the information that you need. So you can get this real-time feedback. If you monitor those reports, they're literally sent in real time. So you can sit there and watch that endpoint, and it'll be like, pop, there we go, something's just happened. So if you want that level of capability, it is there for you to have and for you to use. So again, another really simple one. I like XXP because I don't think we should just leave the default. It doesn't matter what policy setting you choose, but choose it and be explicit. Don't just leave things to fate and see kind of what happens. The next one up, the next acronym in my title, next lightning talk, if you will, STS is Strict Transport Security. You'll detect a very common theme because Strict Transport Security is also a security header. But again, it fixes a different set of problems for us. A lot of websites right now are either already on HTTPS or will be very soon moving to HTTPS. The whole web is driving towards HTTPS. And it's actually happening at a rate that we've never seen before in history. I scan the top 1 million sites on the planet every day, and I track how many of them every day are moving. And this graph, not only are we maintaining the fact that we're moving sites to HTTPS, this graph is actually getting steeper. We're increasing the rate at which we move to HTTPS, which is great. This is fantastic. We should encrypt all of the things. But browsers were built in an age when HTTPS didn't even exist. At one point on the web, HTTP was the only thing that we had. And some of the behaviors and the bad habits linger. So without HSTS, as we call it, it's HTTP, Strict Transport Security. Without HSTS, you open your browser and you want to go to Twitter. Thanks for coming. The vast majority of people will open their address bar and type in twitter.com. And if you type in twitter.com, the blue part here, the browser needs to connect to the site. And to do that, the browser has to have a scheme. We have to use HTTP or HTTPS to get there. And the problem is that right now, even still today, in every single browser that you can go and use right now, if you provide it twitter.com, it will prefix it with HTTP. And it will default to doing the insecure thing. This is still true absolutely right now in every browser. And what that means is that when you type that in and hit enter, you immediately start talking over an insecure connection. You send a HTTP request. Now, if you are going to a good site like Twitter, they will, of course, respond back with a 301 redirect and say, look, we don't do this HTTP thing. We want HTTPS. We want secure. And the browser says, OK, great. That's fine. I will honor that redirect, and I will remake the request over HTTPS. It's not a big problem. I mean, it's a bit of a big waste of time because you've got to do this like whole big thing around the whole transport layer and then go get the page properly. But we end up where we need to be. We end up on a secure connection. But not always. The problem is that the majority of our initial connection to a site is actually secure because the request we send and the response from Twitter is done on HTTP. And that means it's not secure. People can see it, people can meddle with it, people can change it. And the really important thing here is that the 301 that we get back from Twitter to say, hey, you're on an insecure connection right now, let's go secure, we send that over HTTP. We send that over an insecure connection, which means somebody can meddle with it, somebody can tamper with it. So is it a good idea to say, OK, this isn't secure right now, let's go secure? The bad guys will just chop that bit out. They don't want the browser to see that bit. And we're not on a secure connection right now. And this is really easy. It's the most trivial attack that we can do, and it's called SSL stripping. And essentially what happens is when you send that HTTP request to Twitter, the bad guy says, hi, yeah, I'm Twitter. Here's the page that you asked for. And what the bad guy does is they just proxy the request on the other side. So they see your browser ask for the homepage for Twitter, and they go to Twitter on HTTPS, grab the page, and give it to you. So your browser's like, great, I sent a HTTP request, and I got the page that I wanted. Load the page. And it never sees the upgrade thing because it doesn't happen. And this is so trivially simple that if you deploy a website with HTTPS and you aren't using HSTS, then you're not finished, we're not done, because we've got to fix this problem because it's so trivial to do. And this is exactly the problem that STS fixes. So STS, again, it's strict transport security. It's a security header, really easy to configure and deploy. You just set this header on your site and deliver the policy along to the browser. And again, STS, really simple. There's only 3 directives total, and you actually only need to use max age. That's the only one required for a valid policy. Now, this is the number of seconds that the browser should remember that you have enabled this for. So you say, OK, look, I want to turn on this feature, and I want to turn it on for a month. And the browser will remember that and apply this feature for a month. It includes subdomains, does exactly what it says on the tin. If you turn this on for example.com, and that's your website, do you want to apply this to the subdomains beneath it? And preload, that's extra reading. You should have a look at preloading, because you can actually have your domain name written into the source code of every mainstream browser on the planet using preloading. And that's really cool, so you should check that out. But this is an STS policy. That's it. That's all that you need. Max age, that's a month in seconds. And the idea is that if the user comes even once a week, every time they come, they'll top the cache. They'll remember it for the next month again and again. And the protection that it gives you that is so crucial is that with HSTS, you open up your browser, you type in twitter.com, and you hit enter again. Now, Twitter already uses HSTS and has for a very long time. And what will happen is the browser won't actually send this request because HSTS tells it, you can never speak to me on HTTP. You change the default setting in the browser from HTTP to HTTPS instead. So now, not only have we saved that whole trip around the network where we do the whole redirect and server 301 thing, your page loads faster, we're now just going straight to HTTPS. And because the HTTP request is never actually sent, we can just ignore it and just pretend it doesn't exist. Our whole connection is secure all of the time. So it makes your page load faster, and it also makes it secure no matter what happens. And there's a couple of interesting things that STS allows you to do as well. And I just want to show a couple of those quickly. So I'm going to jump over to a site that I know doesn't use this. Not mine. Mine does. I just want to open the network tab. So let's have a look at this. Preserve the log. And despite yelling at them all the time, the BBC still don't use strict transport security. So I type that in there. And as we said, you make a HTTP request. It sends it out over the network. I'll just make that a bit bigger. I don't know if the guys at the back can see. And we send that HTTP request out, and then we get the 301 back to say, look, you need to come back over HTTPS. Now, the BBC has like a horrible redirect chain, and I don't understand why. But ultimately, after being redirected, you get to HTTPS, at the end part of that, but all of those redirects were HTTP. If the bad guy doesn't want you to see them, the bad guy just throws them away because they're not secure. You can't stop them. So that's somewhat problematic. And if you go to a website, and again, I can explicitly try to go to HTTP on my website. Now, as the user, I have told the browser, I want to go to HTTP on this website. And as the user, you are generally, the person sat at the keyboard, you're essentially God as far as the browser is concerned. You are like the most important thing, and if you type it on the keyboard, it happens. What do you think will happen on my site? Will this go HTTP and redirect? So if we take a look, you can see this is the initial request that I made as the user. It tried to go to HTTP, but the status code here is not 301 or maybe 302 as you would expect. It's 307 instead, and it says that an internal redirect took place, and the reason for that was HSTS. Now, it then immediately followed that up with a secure request instead. So the browser didn't send that first request. It didn't go out. It didn't hit the network. It went to make it, and it was like, actually, I'm not allowed to do this because HSTS is set on this site. I've got to go to HTTPS straight away. And the good thing with that 307 redirect, you can time these. It takes less than a millisecond. So that means that that whole redirect loop that would have happened on my site also didn't happen. So this page loads quicker as well. I like that we can get two things from a security mechanism, better performance, and the fact that we've mitigated this whole category of different attacks. So STS is really simple. And the one thing that I would say with it is start with your max age really low. It's one of the most common problems that I see. People say, oh, let's turn this on and test it. And we'll set a year in the cache. You can't turn something on and test it for a year, because if you turn this on and it breaks your website, then you're locked in for a year. That's the cache value. That's how long the browser will remember it. As I said, I track those top 1 million sites, and when Facebook first introduced STS quite a while ago now, they started with the max age at 10 seconds. And that's a really good idea because there's no test mechanism for STS apart from a small max age. So you're like, right, I want to turn it on. I want to see what happens. So we'll go for 10 seconds. So you deploy it onto your site, 10 seconds max age. And it's like, oh my God, like all of these things break, or our JavaScript subdomain can't be secure. Whatever happens, something breaks. The best part is you just turn it off, wait 10 seconds, and just deny any knowledge about what happened because it's all gone. So that one was STS. It's STS. If you're already on HTTPS, this is essential. You cannot consider your deployment done unless you are using STS. It's just too critical an issue. And again, it will make your pages load faster, so why not? We have nothing to lose here. Next one. This is an interesting one. I can hear people chuckling in the front row because PKP is the next acronym from my slide title. And public key pinning is a really interesting mechanism because this is basically the most powerful security mechanism that you could ever deploy right now for your website. And was it Spider-Man that said, like, with great power comes great responsibility? That has never been more true than with public key pinning, because public key pinning is the most powerful security mechanism, or if you use it wrong, it is the most powerful foot gun that you will have ever seen. So I'm giving you this warning on the way in because it's really important that we understand this. Public key pinning is designed to fix a very specific problem that we have online called rogue certificates. If you want HTTPS on your website, you have to go to a certificate authority and get a certificate. That's how this works. And the idea is you go to this CAA and say, hi, I'm scotthelme.co.uk. You prove you own the domain, and they say, OK, here's your certificate. But who here has perfect security? No one. Great. So neither do CAs. No organization has perfect security. Sometimes they get tricked. Sometimes they have breaches. And we end up with what's called a rogue certificate. And it's where somebody gets a certificate that shouldn't have one. So if I get a certificate for PayPal.com, I can tell your browser, I am PayPal.com, and it will give you green padlocks and secure things. And you will think I am PayPal.com. And that's a really big problem. So what we have on the screen here is one certificate that I got as the owner of this website, and one certificate that the attacker got by tricking a CA. They might have hacked them, compromised them, breached their systems. They may have just tricked them, social engineered them. Doesn't matter. Which one of these is the bad certificate? Which one of these should you trust, and which one of these should you not trust? And this is the problem. This is exactly the problem that PKP was designed to fix. And just so you know, that was the bad one. You were wrong. So PKP is another response header. You'll be seeing like a really similar theme through all of these. It's another HTTP response header. You set the public key pins header, and again, inside that header, you set the policy that you want the browser to enforce. Really simple again, we've only got 3 directives. Max age and include subdomains you should be familiar with now, the number of seconds that you keep that for, and whether or not you want this policy to apply to subdomains on your site. And this pin SHA-256 directive is the new one. This is the secret sauce of PKP. Because to deploy a valid policy, you need at least 2 of these pin values. And these pin values are a hash of the encryption key on your server. So when you set up HTTPS, you want to do encryption, of course you've got to have an encryption key. And what you do is you take a hash of that key. It's actually a part of the key. You take a hash of that and put it into the policy. And you're saying to the browser, right, look, I've got my website set up, I have this encryption key, and here is a hash of it. So when you come back and I'm using this key again, you can hash the key and see if it matches. And if it matches, you know that it's me. And the reason you need a second one is because you've got to have backups. In every kind of part of IT and tech, you've got to have backups. So the idea is you go somewhere else and you generate a backup key and take the hash of that. So you're saying to the browser, look, if you come back to my website, the key that I use should match one of these 2 hashes. And if it doesn't, it's not my key. So it doesn't matter who gives it to you and who they say they are, you know that it's not me, because I'm giving these 2 values to you ahead of time. As I said, the hash value itself, if you are technical and interested in this is a hash of something called the subject's public key information, or the SPKI. Essentially, if we don't care, then you don't really need to. You hash part of your encryption key, and the browser can check that every time it comes back to make sure it matches and to make sure that it's still you at the other side, because you've established some kind of agreed secret and say, look, these are the 2 things that I will have. And if you're really technical and you really do care about this, you don't even need to hash your own keys. If you trust your CA enough, you can pin at different levels. And the only reason I bring this up is that if you do go away and consider this, you need to understand the different ramifications of trusting your CA to do this. Again, it's a very complex and very powerful mechanism, and probably maybe only suitable if you're like a bank website, government website, maybe finance, you do a lot of transactions, large e-commerce. This certainly isn't for, Joe's Pizza Shop or, some kind of small-scale site. And again, very similar theme. You can deploy this in report-only mode. If you look at this header here, you will see at the end, it's public key pins report only. So you can deploy this to the browser and say, look, if I gave this to you, what would happen? And also, send me a report again to this address. You'll get that nice JSON payload back. When you can recruit all of your visitors to be part of your QA team and file useful bugs, like we're winning so much at this point, it's really a valuable feature to have. So I'm not going to give a demo of PKP. And the reason that I'm not going to give a demo of PKP is it would be a little bit like me trying to give you a brief introduction on handling weapons-grade plutonium. And if you accidentally touch these 2 things together, you're just going to vaporize us all. This is too dangerous for me to demo. And you should really consider whether or not you need this on your site. Are you a high enough value target? And the reason I say that is, let's say that you're the bad guy right now, and you've hacked a CA, and you can get a certificate for any website on the planet. What domain would you get a certificate for if you could? You're going to go for like PayPal.com? Maybe the Australian government? US government. US government? Maybe Amazon?
More value.
If you ask yourself that question and you are not the answer, then you don't need PKP. That is the test. That is the litmus test for whether or not you need it. If you could get a certificate for any site on the planet, any domain, what domain would it be? And if you put your domain in the answer, then you need this. If not, you probably don't. The other reason for PKP falling out of favor, apart from being really dangerous, is that it's largely being replaced by 2 other mechanisms. You can achieve the same level of protection, but with much less hassle and much less risk, which is the more important part. And that is the next acronym in my title. It's one of the 2 mechanisms that I see over the coming months and years replacing public key pinning as the method of choice, and it's certificate authority authorization. And again, it fixes a very simple problem, but it's a very serious problem. When you want HTTPS on your website, you've got to go get a certificate. This is just how it works. You've got to go to a CA and apply for one. And when you do that and you get one, you get the pretty green things in the browser. You get the padlocks and HTTPS. Now, I use Let's Encrypt as my CA. If you are already on HTTPS and you're paying for your certificates, you don't have to pay for them anymore. Let's Encrypt give them away free. And I only want Let's Encrypt to issue the certificates for my website. But I have no way of saying that. I mean, like, how do I say, I only want this CA to do that? If you go to a CA and say, hi, I'm scotthelme.co.uk, and you try and trick them, you can go to any CA that you want. As the bad guy, you can choose. Now, are you going to go to like a really good, strong CA that's got good processes and they're secure? Or are you going to go to like a really small CA that doesn't have very mature processes or good security? You as the attacker get to choose how you want to attack, and this is a problem. And this is a problem because I use Let's Encrypt, and there's not just Let's Encrypt as a CA. There's hundreds of other CAs all around the world. Some of them are multi-million-dollar companies with whole security divisions, never mind just teams. And some of them are just kind of like, you know, a few guys in a shed that set up. As an attacker, which one of those are you going to go after if you want to try and breach them? You're going to go after the weakest link in the chain because that's what the bad guys do. We're lazy. And this is problematic because you can approach this CA and say, right, I want to try and get a certificate for Scott's website, and let's see if we can trick this CA. Oh, no, we couldn't trick them. Right, we'll try and trick these guys next. No, and you're just going to keep going until either you run out of CAs or you find one that you can get through their process. So as a host, as the owner of my domain, I want to be able to say that I don't authorize anyone else to issue certificates for me, apart from the CAs that I want. And this is what CAA does. By introducing a new DNS record, you can now actually take control of who is allowed to issue certificates for your domain. So we're all familiar with the kind of standard DNS records that we come across. We've got A records, quad A, text records. CAA is just a new type of record that you can set. And this is why CAA is essentially free. Like, you know, hopefully setting a DNS record isn't going to cost you anything. And what we do is we set the issue directive. This is the first value you can set in CAA. And it says, this is the CA that I authorize to issue certificates for my website. So now you as the bad guy, you go to the China Post Office as a CA. You go to the China Post Office and you say, I want a certificate for scotthelme.co.uk. See if I can trick you, see if I can force you to give me one. And they look at this and say, no, sorry, we're not authorized to do that. Problem solved. If you, as the attacker, want a certificate now, the only CA that you can go and try and get one from is Let's Encrypt, because they're the only ones that are authorized to issue a certificate for my site. So the attack surface went from 200 plus CAs in the planet to 1. And now you, as the attacker, are forced to do that. The issue directive lets them issue standard certs, so that contain actual domains. If you want wildcard certificates, they're a little bit more kind of powerful. There's an issue wild directive, so again, you can allow or deny a CA the authority to do that. And again, reporting is a really common thing that we see. This IODEF record here. What this says is, if you as a CA refuse to issue a certificate, tell me that someone tried to get one. Like, yeah, it's great that you've refused it and not issued it, but I'd quite like to know if someone is out there trying to get a certificate for my website. And that is what this method is for. You say, look, just send me an email here, send me a report and say, hey, look, someone's just tried to get a certificate for your domain. You should probably know about this. So we'll take a look at it. I can't actually show it in action as such, but with CAA being such a new mechanism, unfortunately, it's not quite as widely adopted as I would like yet. This came into action, it was the 7th of September last year, so all CAs are now required by their governing body to check these records. So this isn't optional anymore. This is now a requirement. So Google have this cool DNS tool that we can use to look at records, and we can now specifically look up CAA records. So this right now is my actual CAA policy. These are the CAs that I whitelist. If, like me, you have more than one CA, just create multiple records and say, not only do I authorize this particular CA, but I also issue these. I also authorize these other people to issue as well. The issue wild directives are also in there, so those CAs can issue wildcard certificates for my domain, and that's it. Like, we really can't get much more simple than creating a DNS record. And I love these mechanisms where it's essentially zero effort on the way in, and the savings and the benefits on the other side are massive, but it's not widely deployed yet. So let's have a look. I think Google have one. Google have their own CA, so they just authorize themselves. No other CA is allowed to issue certificates for google.com. Who else have we got? I can't think of anyone that actually uses this. eBay? Oh, eBay do. So there we go. eBay have locked themselves to Symantec, and they also have the IODEF set to get emails. So if you go out there and you're a bad guy and you try and get a certificate for eBay.com, not only are you not going to get it, but they're also going to tell eBay that you tried to get it as well. And that's a really powerful mechanism. Again, for sites like eBay, who it would be a really serious issue for if you got a certificate for eBay.com. This is a really good mechanism. The reason that CAA as well is much better than the previous one, PKP, is that if this does cause harm, if this does break, there's no kind of max age like there is in PKP. If these records are wrong, or you've misconfigured it, or you need to change it, you just change DNS. And as fast as you can change DNS, you can fix the problem. So there's no kind of memory effect. There's no lasting harm or damage after you break it by accident. So you need to generate your policy. Now, they look kind of gnarly sometimes, and they can be problematic, but there is a tool to do this, and I would recommend this one. This is the tool that I use. On SSL, mate, CAA record generator. So you literally just go through and say, look, this is me. Whoa, there we go. Yeah. And you come down here, and there's just a list of all the different CAs. And it's like, right, okay, who do we want? I want Let's Encrypt to issue non-wildcard and wildcard, and we'll just have these people, whoever they are. And then you scroll down to the bottom. Would you like to get emails? Well, yes, I would, because that's a good idea. And if you scroll down here, there's your policy. They're the records that you need to go set in DNS. So you open up I'm on Cloudflare, it's really easy. You just open it up, create a new record, select CAA, paste that value in, done. Hopefully that would take you no more than maybe 5 or 10 minutes. And it's not going to cost you anything. DNS records, they should be free, but you're going to get a huge level of protection from that. So I love these easy wins. Any mechanism where, I don't have to do too much is great. So I didn't think that was coming back. There's quite a few there. I appreciate that was like a really kind of quick introduction, and that was kind of the point. What I want to do is introduce you to these different mechanisms so that you can look at them, and maybe you've seen one in there that you think, oh, well, those other ones might not be for us, but that CSP thing sounded really good. So quick overview of each one. If you're on HTTPS on your website, you really want CSP with upgrading secure. Enable reporting, get that real-time feedback. That is a massively valuable feature that you can get. When your visitors will tell you about problems with your site in real time, what's not to like? XXP, please specify this. No matter what value, what policy that you go for, you should be explicit. I don't think that we should kind of rely on defaults, because if we rely on defaults and we're not aware of it, they can change. They may change between different browsers. Chrome and Firefox may diverge on their agreement. They may change what happens. So I think that we should be explicit and make a conscious choice rather than depending on defaults when we're configuring the auditor. STS, another essential one. It forces HTTPS to your website. We get rid of any HTTP comms. So that default HTTP in the browser that's been there since the dawn of the web, you can change that to HTTPS, reap all of the security benefits, save your servers from issuing 301s all day long, make your pages load faster. There's really a lot to be had from a very simple mechanism there. PKP, this is the dark one. This is kind of falling out of glory now, because a lot of people have configured this wrong, and a lot of people have broken their websites. I've helped 2 different companies try and recover from misconfiguring this. So if you do answer that question with your own domain, if I could get a certificate for any site on the planet, if your site is on that list, then do consider this. But again, be warned, it is a very dangerous mechanism. If you get it wrong, you turn off your website, and there's no going back. But that is being replaced by CAA. We can get a lot of the features of PKP from CAA, and it's just a simple DNS record, as we just saw. If you are interested in the second mechanism that I talked about for replacing PKP, it's something called certificate transparency. I'll tweet out some links to that afterwards, and you can read up on that if you want. But the CT deadline for compliance is coming this April. And most website operators that I speak to don't actually know that it's coming in April. So it's probably worth checking that out, actually, and having a look to see if your website is ready for the CT compliance kind of impending doom deadline that's coming. But other than that, security. All of these are security mechanisms. But often I find myself not selling them all of the time on their security value. Reporting is great. Learn about errors on your site. Fix things automatically that slip through to production that shouldn't be there. There's lots of benefits outside of just security as well. So take all this away, secure all the things, make your websites better, and thank you very much. Now, I did leave, and I have got 6 minutes for questions.
Well, I've got 2.
Okay.
The cross-site scripting auditor,
Yes.
your recommendation was to block.
Mm.
To the casual user, they might think your site's been hacked.
Yes.
So is there a better way of dealing with that, or is it, can you
No.
redirect?
Okay, so the question there was, if you configure the auditor to block and the user gets that error message, they might think it's a result of a security compromise on your site. I guess the problem here is, and it sounds like a bit of a cop-out answer, but it's not. It depends on your organization's tolerance to what happens there. Because if you filter, the risk is that your website looks okay and your user gets compromised. Whereas if you block, the result is that your user is safe, but it looks like something's happened to your site. Now, I can't answer that question for you. That's a decision. But this kind of comes back to the point of making the conscious decision and setting the value. Like right now, you're all just going with the default, probably. Most people are just going with the default and don't actually know. Whereas even if you stick with the default, it's still better that you've explicitly and knowingly configured that to happen and can explain that when it does happen, rather than just, right now, most people don't. Second question?
Second question, could you ruin someone's life if you got access?
Yes.
Well, okay, yeah. No, but if you got access to their request, like to their response rather, with the key pinning thing, could you do malicious key pinning and screw them up for 10 years or something like that?
So that's a really good question. The question there basically was, if someone compromises your site and they could set one of these headers themselves, like as the bad guy, yeah, so PKP is an especially bad one for this. If you get a bad guy in your environment, and they can do stuff on your website, setting response headers will be one of the things that they could do. And we actually call this hostile pinning. There is a term for this. And what happens with hostile pinning is, and we saw a really great example of this just the year before at DEF CON in Vegas, they called it ransom PKP. So bad guys get onto your server, and they set the PKP header, and they lock it to a set of keys. And then they deface your website. You know, you've seen the defacements before. They write, you know, hacked by some kid, lol, whatever. And they send out a tweet saying, look, we've just defaced, like, eBay's homepage. What is the first thing that everybody does when they see that in the headlines in the news? They click it. They all go straight to the eBay homepage because they're like, oh, my God, there's, like, funny cat pictures on eBay's homepage. Let's go take a look. When you go to the page, you get the policy. But the users don't know that. It happens in the background. eBay's security team come along, they fix everything, they put their website back to normal, and they're like, okay, everyone, we're good. Come back to our website now. But the browser remembers the PKP policy from earlier. And then when it comes back to the website, the browser now can't load the page. And that's a variant of hostile pinning called ransom PKP, because then the bad guys ring eBay and say, yeah, those 2 pin values we set, those 2 keys, if you want those keys, they're $1 million a piece. Or you can leave your website off, your choice. So this is one of the reasons that this is one of the big reasons that PKP is on its way out, I think, in that it can actually be turned around and used against the host in a very bad way. And it can be used against you even if you don't configure it. Because if I get onto your website, I can just turn it on. And you can't stop me because I'm in control. And it's not so much a problem because if the bad guys get in, of course they can do whatever they want. It's the fact that after I'm gone, it will stay there in the browser. And that's the really dangerous bit. Yes?
STS, what is the browser compatibility?
Oh, like full forever. If you've got any modern browser that's been updated in like... Sorry?
IE 9, IE 9, 10?
No, I think you have to be Edge. IE 11, if you're like super up to date with everything. But if you're using IE 11, then I don't know, maybe you've got other things. That...
So
I'm sorry, I do it all the time. I'm just funny.
But I'm just asking, because I know users. They
yeah?
do not upgrade. So if you have the choice between STS and 301 redirects to STS, or...
So the important thing to clarify there is that you should still keep your 301s in place.
Thank you.
So you should always do that and always keep them because HSTS is what we call a tofu mechanism. It's trust on first use, which means that until that browser has been to your website at least once, they won't know it's there anyway. So they're going to go HTTP that first time, get the redirect, then see HSTS, and from that point forwards, they'll have it. So you still need the 301 because the first time, every time, it'll be HTTP anyway. That's what preloading fixes. Go check out preloading. You get your domain name literally written into the source code of the browser. So even if it's never been to your website, my domain name, and I know this, my domain name is written into the source code of every browser on all of your devices if you've updated in like the last 2 years. So my domain is literally written into all of your devices if you've never been. That's preloading, and that's cool. Everyone should check that out.
Older browsers fall back to the, if you've got an older browser,
Yep.
it falls back, doesn't it?
So if it doesn't support STS? Yeah, so this is the really good thing with all of these mechanisms, is that you set these headers, and the browser looks at the header, and it's not compliant, or it's too old, it doesn't understand them, just ignores them, and carries on as normal. So the absolute worst case scenario for any of these is nothing. And that's what I really like, because that's why I can be fairly broad when I say everyone should deploy this, because it doesn't really matter. The worst case scenario is that nothing changes. There's another question?
The David Gilbertson article that was floating around last week about stealing people's credit card details by...
Yes, I saw this. That was really good.
Haven't read it. The first version of that article said, if you've got a CSP,
Correct.
it's all good.
Yes.
About 2 days later, he changed it and said, oh shit, if you've got a CSP,
Mm-hmm.
you can inject a link tag and you can leak data via a get
Yes.
and a link tag. Is there going to... Clearly, we need to have a link source. Is that right?
Yeah, so there's a couple of things there. If you haven't read that article, I'll tweet out a link after the talk. Find me on Twitter, because it is a really good article. The interesting thing that I found about that is his problem was that he was exfiltrating data. And CSP is not meant to stop data exfiltration. It's meant to stop content injection. So there is kind of a cross-purpose there in that he was kind of relying on CSP to do something that it did, but that it wasn't meant to do.
It was the only thing that did it, though.
Correct, yes. And actually, what we have done now, I pushed in the standards body, and we are actually going to get a prefetch source in CSP version 3, which will be out soon. So you will actually be able to specify things like prefetch, pre-render, etc. as well. So there will be another new directive coming, and that will completely neutralize the attack that was in the article. Questions? There was another, can't see.
You have a PKP on your side.
I did, I don't anymore.
So the answer was your side is the most important side.
No, the answer was, I'm a security guy, and when I don't do things, people ask me questions on Twitter. So, yeah. No, even I've turned off PKP on my site now, in favor of CAA and CT. Any more questions? Oh, yeah, sorry.
Is there any value in PKP report only?
Yes, I see great value in PKP report only.
Protected middle boxes or...
Yeah, so most sites that do deploy PKP never actually enforce it. They deploy it in report-only mode and use it purely as a monitoring mechanism, just to see what's going on out there, because they might be curious. It's like they never actually intend to enforce it, but you can deploy PKP in report-only mode and have it send you those reports. And it just gives you more data to work with, and there's no risk because it can never go wrong. And there was one more? Yes?
Yeah, there is out there this discussion what is more secure, saving the login token in a cookie or in a browser local cache, because cookie is always sent with each request, and if you save it in JavaScript in the browser, it can be hijacked by JavaScript. What is your suggestion? Which way you would?
So just run that question by me again, sorry, make sure I understood it.
So where should you store the login token? You should use
Okay.
cookies for that, or?
Yeah, I mean, I do use cookies, and in all of my services that I run and the sites that I work with, we still use cookies. We have the secure flag to make sure they're always transmitted securely, and the HTTP only flag to make sure they can't be read by script. But if you start coupling that things with like CSP to make sure that hostile script can't get in, that's another line of defense. And if you're interested in cookies and auth tokens like that, check out something called same-site cookies. And I wrote an article called Tough Cookies. If you Google it, it lists all of the extra stuff that you can do with cookies. And there's actually quite a lot that we can do to protect them. So have a look for my Tough Cookies article. I'll have to wrap it there. I'm over time. I'm hanging around all night. If there's any more questions, please come and find me. Other than that, thank you very much for coming.